Okay, welcome to this course on microprocessors. So today we will give an introduction to what microprocessors are and how they are different from microcontrollers and microcomputers, and what are the applications of microprocessors in daily life, and what is the history of these microprocessors, how they were evolved. So microprocessor, if you say the term microprocessor, it is basically defined as a programmable device or programmable machine, a programmable electronic device that reads some instructions from a storage device called memory and processes and accepts binary data as input and processes this binary data as per the instructions just stored in the memory and generates the output. Okay, so we'll discuss about all the basic terms that are used in this definition. So you have a microprocessor, which is basically a integrated circuit, in fact, electronic circuit. So it is basically processing or computing element, okay, and it is a multi-purpose machine. So you can perform many tasks using the microprocessor depending upon how you instruct it, okay. So you can instruct a microprocessor to accomplish a variety of tasks, starting from very small tasks, maybe just for home appliances to turn on or off a switch, to some sophisticated tasks or high-end level computing. Okay, so you have a input. So microprocessor is a computing device, okay, programmable computing device. So to make a complete system, you need to connect it to some input device, and along with that you need a memory location, storage, where the instructions for the microprocessor will be stored. So this microprocessor will fetch those instructions from this memory and it will process the data. So that data can be from an input device or this data can be from the memory also. So there is a two-way communication between the memory and microprocessor, and it gives you a output. So that output is in general in digital form, but if you want to display this data on some LCD or LED display or some you want to printer, so you can have connect external output device for that. Okay, so this is a general, you can say, block diagram of a microcomputer. Okay, this is called as microcomputer. So microcomputer is basically a computer in which the role of CPU is replaced by microprocessor. Okay, so if you see the microprocessor itself, it has different, you can say, components which are basically integrated on a single chip. So it contains ALU, which is called as arithmetic and logic unit. Then you have a register unit, which is used for temporary storage of data during the execution of the program. And then you have a control unit. Okay, this is what is actually inside a CPU of a computer. So you have a arithmetic and logic unit, which is used to perform various arithmetic and logical operations like addition, subtraction, logical operations, and or so on. And then you have a register unit, which contains several registers which are used for the temporary storage of data during this processing. And the control unit, it basically sends various control signals, generates various control signals through which all these devices, input, output, and memory, they communicate with each other in a proper fashion. Okay, the communication is basically controlled by the control. Okay, this is what is done in the earlier designs of central processing units. Okay, so we have separate unit for ALU, you have separate unit for registers, you have a separate unit for control signals. So now all these elements or these components, they must be connected together. So in general, in a CPU, they are connected through some copper wires for transmission of electrical signals. Okay, so this processing unit is somehow becomes bulky in size, and it is very, you can say, speed is not so fast because of this copper wire connections. Okay, so then the term microprocessor came. Okay, so in the microprocessor, what they have done, that the CPU of this computer, it was replaced with a microprocessor. So microprocessor became as the central processing unit of the computer, and it was named as microcomputer. Okay, so how this microprocessor is not different from your general CPU. In the microprocessor, all the three units, ALU, register unit, and the control unit, they were integrated on a single integrated chip. Okay, and then the microprocessor was basically born. Okay, so it happens in around 1917s when Intel first time coined this term microprocessor. Okay, so microprocessor contains all the three blocks: the arithmetic and logic unit, the register unit, and the control unit on a single chip. Okay, so these different components, they form the hardware. Okay, and the set of instructions that is stored in the memory of this microcomputer, based on which this microcomputer works, that is called basically the software. Okay, so microprocessor based applications, they are classified into two categories. One is reprogrammable systems, another is your embedded systems. So in the reprogrammable systems, the microprocessor is generally used for computing and data processing. Okay, so as the name itself suggests, so reprogrammable system means you can program the processor to perform different tasks as per your choice, all the within the capability of the microprocessor. Okay, So it generally involves general purpose microprocessors which can handle large data, okay, and has higher memory addressing capability. Okay. So computer is basically a typical example of a reprogrammable system. So another category is embedded systems. In the embedded systems, the microprocessor is not available to the programmer for programming. It is a part of an end product. Okay. So in the embedded systems, your microprocessor is a part of final product or end product and is not available to the user for reprogramming. Okay. So embedded system means where a microprocessor is used for one and only one task. Okay. So it is fixed in a machine, so where it has to perform a dedicated task. So it is already programmed accordingly, and the program is burned permanently in the memory, and you finally get a product which is used for a particular task. Okay. So it may be like you're using a embedded system or a microprocessor based system in the washing machines. Okay. So in that you use a microprocessor as a microcontroller, but that is not available to you for the programming because it is the part of a final product. Okay. Similarly, in automobile dashboard controls, traffic light controls, okay, dishwashers, washing machines. So there are many examples which are fall in the category of embedded systems. So embedded system means where the processor is dedicated for a particular job. Okay. So it is programmed in a particular way and the program is permanently burned in the memory, which is not changed. Okay. So embedded systems can be viewed as basically microprocessor based products. Okay. And then after this, uh, in the market came microcontrollers. So microcontroller is basically a complete microcomputer where the processing unit, that is your microprocessor, the input, output, and the memory, they are all integrated on the same chip. Okay. So all of this is integrated on a single chip, which becomes a microcontroller. Okay. So it has its own microprocessor for data processing, its own memory for storing the program and the data, input ports, output ports, and even some microcontrollers, they have inbuilt A to D converters and also some ports for serial communication, serial input output communication. Okay. So microcontroller is a complete microcomputer where all these elements, they are integrated on a single chip. Okay. So for most of the embedded systems applications, microcontrollers are used. Okay. Because if you use a microprocessor for embedded system, so you microprocessor is just a processing unit. Okay. It is a computing element, so you have to integrate some input with it, you have to integrate a memory with it, and then only it can become functional. Okay. So anyhow the size will become large, right? So, but if you use a microcontroller, so in the microcontroller everything is on the single IC, single chip. You have microprocessor, you have memory, input and output ports. Okay. So you have to just program it and it can be used for any embedded system applications. Okay. So microprocessors are generally used where we need to handle large amount of data or high speed computing. Okay. For small applications where the program can be stored in a small space, so we generally prefer to go for the microcontrollers. Okay, so this is what is the difference between a microcomputer, a microprocessor, and a microcontroller. Okay, so microprocessor is a data processing device. It's a digital integrated circuit, in fact. Okay, which operates on a certain set of instructions that are designed for a particular microprocessor. Okay, and those instructions, they define the capability of a microprocessor. Okay, that which tasks they can be performed by the microprocessors. We will come later on this when we see what is the instruction set and what is the machine language and so on. But in general, microprocessor is just a processing unit. So by processing means it accepts some input and it processes it according to the set of instructions that are given, and it generates the output. Okay, so those instructions, they must be stored in some storage device, which is a memory. Okay, and the input data, it should come from some device. Input device may be a keyboard or a switch or some sensor. Okay, and that data is processed by the microprocessor and it is sent as output to a output device. Okay, so in the microcomputer, the CPU is replaced with a microprocessor. Okay, so a computer in which CPU is microprocessor, that is basically called as microcontroller. Sorry, microcomputer, and then we finally have a microcontroller in which the microprocessor, the input output ports, and your memory, A to D converter, everything is integrated on a single chip. That becomes a complete microcomputer. So microcontroller itself is a complete microcomputer, in fact. Okay. So and all these devices, microprocessors or microcontrollers, the input data they accept are the data that they process. They process only the binary numbers. Okay, in fact, they have their own language, which is called as the machine language, which is a language of digital numbers or binary numbers, that is zeros and ones. Okay, so for every processor, there is defined that how many bits the processor can process or the handle. That is called as word size of the processor, or we call it as word length. Okay, so you have 8-bit processors, you have 16-bit processors, 32-bit processors, 64-bit processors, so on. Okay, so 8-bit processor means the word length of the processor is 8-bit. So by word length means it can process 8 bits at a time. Okay, suppose if you want to add two 8-bit numbers, so they can be added in a single shot using a 8-bit processors. Okay, if you want to add two 16-bit numbers using 8-bit processor, in fact, you have to do that addition using 8 bits only. Okay, so word length of a processor is very important. You can say parameter which defines the speed of operation. Okay, because see, the more the number of bits the processor can handle, in fact, the more will be the computational power. Okay, the processors that were developed initially, they were only the 4-bit processors. Okay, so it means they can handle only 4 bits at a time. So the data they process, that data must be represented in 4-bit format. Okay, so with the advancement in these uh, fabrication technologies, so as we have moved from small scale integration to large scale, then VLSI, then super scale integration. So nowadays we have processor in the market which can process 16 bits, 32 bits, 64 bits at a time. Okay, so the word length is much higher. It means their computational power is now much higher as compared to their earlier counterparts. Okay, so microprocessor, in the definition, we have said that Microprocessor is a programmable device. What does it mean? Programmable device means a single microprocessor can be used for a variety of tasks. Okay, what you need to do is just change the program in it. Okay, suppose you have microprocessors right now which you have used for some embedded system applications. Suppose you are using it for traffic light controls. Okay, so anyhow, if somehow you want to use this microprocessor maybe for controlling some conveyor belts, so you can use the same microprocessor. The only thing is that you have to change the program or the set of instructions. Okay, so that is what is a programmable device. And see, whenever a microprocessor is designed, along with that, there is a set of instructions which are provided by the manufacturer. Okay, so those instructions only you have to provide to the microprocessor. So whatever task you want to achieve, you have to select one of those instructions from that set only. Okay, so suppose if you have a 4-bit processor. Okay, so 4-bit processor means how many possible combinations you can generate is 2 to the power 4, that is 16. Okay, so you can have from 0 0 0 0 to 1 1 1 1 bit patterns. Okay, now each bit pattern may be used by the developer or the designer for a particular application. Okay, this is what is one instruction. Okay, so instruction is basically nothing but a pattern of binary digits that is already defined by the designer. Okay, so it means if you have a 4-bit processor, you have 16 possible combination of these binary digits. So the microprocessor at most you can perform 16 operations. Okay, so it may be possible that, for example, 1001 bit pattern is used for adding two numbers. Okay, so how it is done basically, once you write a program, so in the memory we basically store this binary instructions. Okay, so suppose you write instruction 1001 in the memory, and when the microprocessor will fetch this instruction, it will decode it and then it will execute it. So because since it is a binary instruction for adding two numbers, so it will send a control signal and it will activate the corresponding logic circuit and the two numbers will get added. Okay, so like this. So but there is a maximum capability of this microprocessor now. Okay, so you can have maximum 16 operations that can be performed. Okay, so how many operations the processor can perform, that is basically what is called as an instruction set. Okay, and each instruction is nothing but a set of binary numbers, and this is done at the design level. So which binary pattern is chosen for which operation, that is done by the designer. And in fact, different microprocessors, they have different instructions. Okay, similarly, if you have a 8-bit microprocessor that we'll study in this course, like we are the processor that we'll discuss in detail in this course, it is Intel 8085. Okay, so it is a 8-bit microprocessor. So 8-bit microprocessor means the word length of this processor is 8 bits. Okay, so the data and the instructions, everything is handled in 8 bits only. So 8 bits, it means you can have 2 to the power 8, which is 256 different instructions you can have. Okay, so starting from 00000000 to 1 1 1 1 1 1 1. Okay, and it may be possible that okay, not all the 256 instructions are used by the designer. Only few of the binary patterns they are used by the designer, and that is what is actually happens in the microprocessors. If you see in 8085, not all the 256 instructions or bit patterns are used. Okay, and these instructions, which we call as the machine code, machine language, they vary from processor to processor. Okay, so it is not like that only we have one microprocessor of 8 bits in the market. It is by Intel. There is another microprocessors by Motorola, which is Motorola 6800. So it is also a 8-bit processor. But if you see the instruction set for this processor is entirely different from 8085. Okay, because that is designed by a different company or a manufacturer. Okay, so it may be possible that okay, suppose in 8085 if they have used this pattern for performing the OR operation, so in 6800 microprocessor they may have used this for a different operation. Okay, so the machine codes or this machine language for different microprocessors, they are not in general compatible. Okay, so that is why whenever you start with any microprocessor, the first thing you must go to the user manual of this IC, so which lists all the instructions which the microprocessor can do. Okay, so there is a set of instructions for every microprocessor, and corresponding to this we have a machine code for this. So in fact, what is burned inside the memory are these machine codes, the binary patterns. Okay, and since the microprocessor understands what is the meaning of this bit pattern, what is the meaning of this bit pattern, and so on, so whenever it reads this pattern from the memory, it decodes it. Okay, so there is an instruction decoder inside the processor also, so it decodes it and gets to know that what task is to be done. Okay, and after that there is a control unit, so the control units will send some control signals to the functional module, the associated logic circuit, and that operation is performed, and all this is done in a sequence. So fetch the first instruction, decode, then execute it. So fetch, decode, and execute, these cycles are operated in a sequence, and the microprocessor will go on performing the task till it comes or it sees instruction which is called as halt. Okay, where you want the microprocessor to stop the execution of the program. Okay, so this is what is the meaning of a programmable device. Okay, so programmable device means there is a particular set of instructions for each microprocessors, so you can choose particular instructions from those set. Those instructions can be loaded in the memory. So when the microprocessor starts, it starts reading those instructions from those memory locations and starts decoding and executing those instructions. Okay, so you can use a microprocessor for a variety of applications depending upon the instruction set available. Okay, so a simple example of a microprocessor based system may be a temperature control system. Okay, so where you have a microprocessor and then you have some buses here, data buses and address buses. Okay, so it is basically a group of wires, nothing when we say bus. Okay, so this microprocessor may be used to control the temperature of your room. Okay, so in that case what will happen, you must have some sensor here or a temperature sensor. So this temperature sensor will generate analog voltage corresponding to the temperature Okay, and since it is an analog signal and the microprocessor can process only the digital or the binary signals, so it must be converted into digital using a to D converter. So this A to D converter is now given as input to this microprocessor. Okay, and now see in the microprocessor you must have some program written, stored, which is used to control the temperature of the room. It means this processor must sense this temperature level, and depending upon the temperature level, it will either turn on some, suppose you have fan or AC, or it will turn on a heater. Okay, of course you need memory also here. Okay, so the program for controlling this room temperature is stored in the memory. Okay, and how you write this program, that you have to write according to some logic, but using the instruction set of the microprocessor that you are using, only those instructions which are available. Okay, so if that program is stored in the memory and you start the system, it will sense some temperature from this temperature sensor, which will be converted to a digital signal using a to D converter and taken as input to the microprocessor. Okay, now this microprocessors will see whether this temperature is above a certain threshold or it is below a certain threshold. I mean the decision making will be taken, and accordingly it will either turn on the fan if the temperature is high. If the temperature is low, it will turn on a heater. Okay, this is what is a microprocessor based system application. So you can have so many applications. Okay, so this is a programmable device now. So if I want to use the same microprocessor for a different application, if I want to use it to control the traffic lights, so I can just reprogram it. Okay, so it can be used for different tasks. So that is what is a programmable device. Okay, so we will continue further with this on this next lecture.